Alright, so hi guys. So in this video, what I want to do is actually, get into one of the, so I guess in every video, what I'm going to be doing actually is basically doing, so I'm going to be doing the rule, so the rule that I'm going to be introducing for every video, and then I'm going to also do something that is called equation of the tangent line. So at a specific point, I'm only saying that because in the book, apparently that's how it's done. And basically, I'm not going to. I mean, yes, I will try to work out each problem, and then I'll explain how I did it, and then I'll explain how the book did it. But first, what I want to do is I want to first go over the basic, so the derivative rules, and honestly, I don't know if I should do them more split up, where I do one rule for one video and then another rule for another video and then another rule for another video. I guess in reality I will just do I'm gonna just do that. Like, I'm gonna do one rule per video, and then at the very end, once we review derivatives, I'll do a mix of problems. Okay, so of course we already know what the equation of the tangent line, or the slope of the tangent line is, not the equation of the tangent line. But from the last video, we said that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, right? But now it's time to kind of, make our lives a little bit easier with these. One thing I do want to say is that in this calculus series, we are not going to be doing derivatives of absolute value, and there's a reason for that. That is because absolute value functions, I believe they're not differentiable. Like differentiate meaning that you can't take the derivative of it. So that's the only one that we're not really going to be looking at for limits and not for limits and derivatives, but for derivatives, or even for critical point. Like, once we get into finding the maximum and minimum by using derivatives, we're not really going to look at those. But the first rule that I really want to introduce is the power rule, okay? And I'm gonna just go ahead and do, like, I'm gonna try to do, like, what is it called? I'm gonna introduce maybe two of them in this video. So there's the constant rule, that is d dx of any number c is just going to be 0. And where c is any integer. And then there's also the power rule, okay? There's the power rule. Now, okay, I'm just gonna, for this video, I'm gonna introduce every rule, because I feel like if I introduce power rule for variables versus the power rule whenever we have a power function, I don't want to confuse you guys. I'm gonna just introduce every every derivative rule here, like in this video, okay? Because I feel like if I do it separately for each rule, there's going to be confusion as to what we're naming it. So the first one, well, that's one. This is one. And this is called the constant rule. The second one, I'm going to say is d dx of x raised to the n power is going to be, so like this, it's going to be n times x to the n minus 1 power. So that's interesting. So like, okay, so the constant rule, for example, if I say the derivative d over dx of 5, that's 0. Okay, any number, it doesn't matter. d dx of, even d dx of e, because e is approximately 2.71, that's 0. Okay, d dx of 7, that's 0. d dx of negative 2, that's equal to 0. Okay, and basically, and then there's this one that says, you know, that says, what is it called? It is the power rule. So I'm going to just do an example. So let's say I want to do, so f of x equals x squared, right? And I want to find f prime of x. What am I going to do? I'm going to grab the 2 here. So let's pretend this is 2. I'm going to grab it, move it to the front, 2, and then I'm going to say times x. And then I'm going to decrease the exponent up here by 1. So it's going to be 2x to the 2 minus 1 power. That's just going to be 2x to the first, which is 2x, okay? Similarly, when I say 3x squared, d over dx, or d dx of 3x squared, that's going to be 2 times 3x to the 2 minus 1 power. That's going to be 6x to the first power, which is just 6x, okay? That's the power rule. And let's say I have something more weird. d dx of x to the negative 6, okay? And you're thinking, like, you know, how do I do that? And it's simple. You're just going to move negative 6 to the front, x to the negative 6 minus 1. This is negative 6x to the negative 7. Okay, this is negative 6, and if you want, you can turn it into a power, or into a rational. You're going to say negative 6 over x to the 7. That's if you want. These two are correct. They're the same thing. That's if they ask you to remove any negative exponents for this one, for the division rule. Okay. What else? Hold on. Now, there's that one, and then the next one that I want to show you guys is the product rule, or actually, well, we're going to do the addition rule first. So that means anytime we have a function of, like anytime we have two functions added together, so d dx of f of x plus or minus g of x, this is the addition or subtraction rule. This is equal to d dx of the derivative, and the way that we read this is the derivative, we read d over dx as the derivative with respect to x, okay? So d dx is read as the derivative with respect to x, because you're taking the derivative with respect to the x-axis, okay? And let's see, so this would be d dx of f of x plus or minus d dx of g of x, okay? And that's another one. Now, there's one that I do want to go over called, okay, there's one I do want to go over called the product rule. This one is called the sum difference rule. This one's the power rule. This one's a constant rule, okay? The fourth one that I want to go over, let's say we have two functions, f times g, or let's do f of x times g of x. What you're going to do, now this is something that we have to pay attention very carefully, okay? So you're going to take the derivative, it's going to be f, so let's pretend we have d dx of fg, okay? Fg, meaning that f is a function and g is a function. So we have, this will be, we're going to do f prime, the derivative of f, so it's going to be actually like this, hold on. d dx of f times g, okay, like this, plus d dx of g times f, okay? The way that they write it, so let's say you have fg prime, this is going to be f prime g plus g prime f, okay? F prime being the derivative of f, g prime being the derivative of g. We'll work some problems out at the end, but those are just how that's kind of how you do it for that. Now the next one is the quotient rule. This is almost the same as the product rule. This one is called the product rule. Okay, that's called the product rule. This one is called the product rule, basically. The quotient rule is a little bit different. If you have f over g of x d dx of this is going to be f prime g minus g prime f over g squared, okay? You're going to take the derivative of the top times the bottom minus the derivative of the bottom times the top, which is, so basically, okay, the derivative of the top, which is f, times the derivative, times the bottom, actually, which is g, minus the derivative of the bottom, which is g prime, times the top, which is f, all over g squared, okay? And again, like at the end, I'm going to go over some examples, and yeah. So basically we have quotient rule, and then we have We have another one called chain rule. This one's a little harder. If we have a composition of two functions, f of g of x, so let's pretend, hold on. This is equal to f prime of g of x times g prime of x. Okay? That's chain rule. Now there is a way that they do this. They do like du dx times something like that, and I won't lie, that to me is a little harder to remember. But the way that they remember chain rule is you take the derivative. So basically if we have x plus 2 squared, so basically if we have d du of u raised to the n power, where u is a function of f. So basically if we have d dx, or actually, hold on. If you want to find the derivative, so give me 1 second. F prime of x of, so I'm not sure exactly how to write this, but what I'm trying to say is that when you have a function within whatever, so basically if u is a function of f, this would then be equal to d. So basically it'd be oh my goodness, how do I say this? What I'm trying to say is that d dx of f of g of x is going to be equal to d dx of g of x times d dx of f of g of x. That's what I said over here. I'm going to do examples like in a little bit, but that's how you would do it. What else? I'm trying to think. One of the things that we should know, well, actually, hold on. So let's just try to take the derivative of the square root of x. Now, again, so if you, for example, let's say we have f of x equals square root of x. I'm just going to go ahead and explain this one this way. Because I'm not going to say that we should all know what the derivative of square root of x is, because, I mean, yeah, this is kind of introduction. So, what you're going to do, the best way to find this one, is to switch it to, what is it called? To power, to a power, like with to exponential. So basically, to exponential form. So we have f of x, and let me actually, okay, so the square root of x, for example, I mean, the way you can do this one is, by turning it into exponential form, so like with the exponent on top, or like, yes, an exponential form basically. So you can say that this is equal to x raised to the 1/2 power. Now you can go ahead and say that this is just, basically f prime of x is just equal to 1/2 x to the 1/2 minus 1 power, okay? And then you can say, okay, well, this is equal to, so f prime of x is equal to 1/2 x, and then 1/2 minus 1. If you don't know how to do that, that's just 1/1 minus 1/2, and it's going to be 2/2 minus 1/2, which is just 1/2, but it's 1/2 minus 1, so it's going to be negative 1/2, and this would be your answer. Now, if you want to turn that into square root form or radical form, you can do that. So you can say that this is equal to basically, so you can say that this is equal to 1/2 x, and then, so let me actually do something, hold on. So it's times x to the negative 1/2, and then you can say, you can do the radical rule where it says x to the m over n power equals the nth root of x to the m. So basically, we have 1/2 times the square root of x to the negative 1. This is equal to 1/2 times the square root of 1/x. So then this is equal to 1/2 times the square root of 1 over the square root of x. And this is just 1/2 square root x. Now, if you want, I mean, I don't think you, like, honestly, I wouldn't rationalize the denominator. I would just keep it like this. This is f prime of x. It's okay to do this. You don't have to rationalize it, because in calculus, there are going to be times where you're not really going to have to do that. And also, it just really depends on what choices they give you. This can be, you can also do it this way. But sometimes, and the reason why I push you, and, in this video, I also, whoever's watching this, I push you to think more, like, go further, because, the reason is because we want to know, like, again, how to actually turn this into radical form, like we did in college algebra, and know how to actually do it for other derivatives as well. So, let's see, hold on, give me 1 second, guys. So this one, again, we want to find the derivative. What we're going to do, we're just going to do the power rule. So we're going to say f prime of x. We're going to bring the 2 down, 2, and then we're going to do times 3x, and then we're going to decrease it by 1, so to the 2 minus 1 power, plus, and then we're going to do 6. So basically, for 6x, or any number that has, so basically, ddx of c times x is just a constant. So right here, the derivative, it's like the slope of 6x. What's the slope of 6x? It's 6. So the derivative of 6x is 6. Derivative is just slope, really. So then we have, and then we do and the derivative of a constant is always 0. So it's going to be minus 0. So then we have f prime of x equals 2, so it's going to be 6x to the first power plus 6. And then we have f prime of x equals 6x plus 6. Okay, that would be your derivative. Let me do another one. So try to see in my book here. Let's see. Give me a second, guys. I'm looking. So another one I can say f of x equals x squared minus 7x plus 6. This, so f prime of x is just going to be 2 times x to the 2 minus 1 minus 7x to the 1 minus 1 power. And then you have plus 0. So then you have f prime of x equals 2x to the first power minus 7x to the 0 plus 0. So this is going to be f prime of x equals 2x minus 7. Okay. That's how you do it. The more you practice these, the better, because then it's going to start to be very simple and you won't have a problem doing these anymore. I know for me, it took maybe a few times, like a few tries to be able to like do it in my head. But like I always say, the more you do it, the more it becomes ingrained in your memory. So that's what I mean. That's how math works, is the more you do it, the more it becomes, you become like, you memorize it better that way. Now, let's try to do, let's see. Let's try to do one that's like this. Okay, and let's say you're like, oh, well, I'm not sure how to do this one because it's in this form. That's fine. I mean, in reality, you can just change this to a polynomial. Okay? So really, you're gonna have f prime of x, or not f prime of x, excuse me. It's gonna be f of x equals 2, and then you're gonna do times, and you're gonna do x squared plus 4x minus 3x minus 12, because you're going like this using FOIL method. And you have f of x equals 2 times x squared plus x minus 12. You're going to go ahead and distribute the 2 in. Okay. And then you're going to go ahead and say, okay, well, this is f prime of x equals, so f prime of x equals 4x plus 2, right? And that's how you do it. Because you do 2x, so it's going to be, I'm going to do it step by step. So f prime of x, and you're going to do 2. So you have f prime of x equals 2 times 2x to the 2 minus 1 plus 2, because remember the slope of 2x is 2, and then minus 0. So you're going to have f prime of x equals 2, or it's going to be 4x to the first plus 2. So it's going to be f prime of x equals 4x plus 2. Okay. This is a lot easier than having to do the limits rule, or you know, doing it that way, because it saves a lot of time. It really does. Let's say, for example, I have something like like this. And you're like, oh my, like, how do I do this, right? Because we don't really know what's, I mean, even though I did kind of like briefly mention it in this video, quotient rule, but you don't really have to use quotient rule for this, if you think about it. In reality, you can factor out x cubed, or not x cubed, x, so you can say f of x equals x times 2 plus x squared over x times x cubed. So then this cancels out. You have f of x equals 2 plus x squared over x cubed. And again, you're like, well, how do I do that? How do I take the derivative of that, right? You can split it into an addition of two fractions. So you can say that this is equal to 2 divided by x cubed plus x squared over x cubed. And then you ask yourself, okay, well, you know, you're still wondering, like, how is that any easier, right? If you look at this right here, remember how I said how in college algebra I had said, and there's x to the negative n, this would be 1 over x to the n, always. Now, what does it mean in terms of this? That means that this is going to be equal to 2 times 1 over x cubed, and then plus, and then you have, here you can say x to the negative 1, and you can keep it as a negative, because that way you can do power rule. You don't even have to do it as a fraction here. Okay? You use laws of exponents here. So then you have f of x equals 2 over x cubed, or, my bad, no. It'd be 2, and then 1 over x cubed is just really x to the negative 3 plus x to the negative 1. And then you have, so then that means that f of x equals 2x to the negative 3 plus x to the negative 1. Now to find the derivative, f prime of x, you're going to do negative 3 times 2 times x to the negative 3 minus 1 power. And that's going to give you, and then you're going to do plus, and you're going to do the derivative of x to the negative 1. That's going to be negative x to the negative 1 minus 1 power. So then you have f prime of x equals negative 6 x to the negative 4 power plus, or actually it would be minus, because we have negative x, minus x to the negative 2, right? So then your answer would be negative 6x to the negative 4 minus x to the negative 2. Now, if your professor or if your teacher wants it without any negative exponents, you're going to say the following. F prime of x equals negative 6 times 1 over x to the 4th. And honestly, the x, remember when, like, I believe I said this in my college algebra videos, that whenever you have a negative exponent, you just move it downstairs. So it's going to be x to the 4th on the bottom, and then minus, and then you're going to say 1 over x squared. And this would be your answer. Now, if they push you further and then they say, okay, well, try to make it into one fraction, all you really have to do is say that this is equal to, and you can use the a plus b plus or minus c over d equals ad plus or minus bc over bd rule, like this. And you can say that this is equal to negative 6 times x squared minus 1 times x to the fourth over x to the fourth times x squared. So then this would be negative 6x squared minus x to the fourth over x to the 6th power. And you can factor out x to the fourth, or x squared, excuse me. This would be negative x to the fourth minus 6x squared over x to the 6th. And you can factor out x squared. So you can say x squared times negative x. Or actually, I'm going to try to do this. Hold on. Or no, actually, I'll just keep it like that. So it's going to be negative, it's going to be x squared times negative 6, negative 6, or actually, no. Sorry, guys. It would be x squared times negative x squared minus 6 over x squared times x to the fourth. And it's really up to you, like, whether you want to write it this way. So basically you can say negative x squared minus 6 over x to the fourth, or you can say it like that. I mean, in reality, I think they just give it to you like this. They give it to you like this mostly, so I wouldn't try to, like, subtract that out. If they're making you do that, then, I mean, gosh, that's like, that's a little bit too much, but that's how you do it for a problem like that. Let's see. Now I did want to go over the trigonometric limits, but the only ones that I will go over are so the only ones I will go over are sine and cosine. And in the next videos, once I do product rule and, you know, stuff like that, I'll go ahead and do, what is it called? I'll explain the other, like, I'm not going to go over all the trig ones here, but I'm going to just say these two. So, for example, these are just two of them. One thing you always have to remember is that the derivative of sine of x is equal to cosine of x, and the derivative with respect to x of cosine of x is just negative sine of x. It's the negative one. It's the negative, so they kind of complement each other, but I feel like this can be really, like, you can forget this so easily. So that's kind of why whenever I say, the way I like to do it is I would say, okay, we have sine of x, and then we have the derivative of sine of x would be cosine of x, and then the derivative of that would be negative sine of x, right? So those are just two of them that I want to go over. I'm not going to go over the derivative of tan or cotangent or cosecant because I feel like those, I mean, honestly, I feel like those require and also sine squared and cosine squared or tan squared, those require the chain rule and the product rule, or not the chain rule and the product rule, but like the chain rule and the quotient rule. So I'm going to stop right here for now. I I hope this helps, guys. If anybody has any questions, please let me know. Yeah, I mean, the only thing that I probably did not do, or actually, let me just go ahead and do a problem really quick. Or no, I'll leave that for the end, for once we learn all the derivatives, because I feel like if I do equation of the tangent line, that's just gonna add on to it. So I don't want to do that, at least for right now, but if anybody has any questions, please let me know. Thank you so much for watching, guys. Please like, comment, and or subscribe to my YouTube channel. And I will see you guys in the next video. Bye, guys.